This video is about graphing logarithmic functions, which are an example of an inverse function. So an inverse function is one where you switch the x and the y coordinates. So here on this first slide, we've got an example of y equals 3x and y equals 1/3 x, which are inverse functions, and an inverse function is also a reflection in the line y equals x. So the function that we're going to be exploring is the inverse of the exponential function. So we know how to graph an exponential, and a log is just the inverse of that exponential. So let's take a look at how to graph it. So when we graph our exponential function, we usually use two key points, and then we have the asymptote. So our first key point is 0, 1. And our second one is 1, 10, which is chosen because of that base here. We also have a horizontal asymptote at y equals 0. Our log graph is the inverse, so we switch x and y. So our two key points are 1, 0, and then 10, 1. And our asymptote is no longer horizontal, it's now vertical. This table of values here just fills in the key points so that we can graph it to see what it looks like. For x is 0, we can't get a value for y, that's where our asymptote is. For x equals 1, we get 0. 10, we get 1. 100 is 2. 1/10 is -1. And 1/100th is -2. You can put those into your calculator, or you can use solving and evaluating the logarithm skills that we did earlier to prove that. So let's put on our exponential graph here first. We've got 0, 1 and 1, 10, and we've got our horizontal asymptote right on the x-axis, and I'll do that in blue. And we know that it kind of goes like this and then approaches the asymptote on that left-hand side. So that is our exponential graph. Our log is a reflection about the line y equals x, which goes right through the center here. And our two key points are 1 and 0, and then 10 and 1, so right over here. We also have a vertical asymptote, which is right on the y-axis at x equals 0. And my log graph kind of goes like this, the reflection of the exponential graph. So then we can add on here the domain and range of those two key graphs. I'll see if I can do them while we can still see them. Not really. So the domain of the exponential one, that is -infinity to infinity, just like before. Our range is going to be from 0 to infinity. Our y-intercept is 0, 1, and our x-intercept is none. Asymptote, y equals 0, and then for our log graph, if I go back, you can see it here. So my domain is going to be from 0 to infinity, which is actually the range of my original function. That is true for any inverse. And then my range is going to be -infinity to infinity. The y-intercept is none because there is an asymptote there, and my x-intercept is 1, 0. So also, if you notice, kind of the opposite of this one. Our asymptote is a vertical asymptote. This one is x equals 0. So what we want to do is be able to sketch some transformations. So our vertical stretch is our A value. This is our vertical stretch, compression, or a reflection, just like it was before. Our K value is a horizontal stretch or compression. Our D value is a horizontal transformation. And our C value is a vertical translation. So those are the same key features that we had for our other functions. Now we're just going to practice applying them to our exponential function or our logarithmic functions. So here we're going to graph y equals log base 10 x minus 2 minus 5. So I'm going to identify first the two transformations that are occurring here. We've got a horizontal shift to the right by 2, and we've got a vertical shift down by 5. Those are my two transformations. So the first thing to note is that this horizontal shift, this affects my vertical asymptote. So my new vertical asymptote is now at x equals 2. So I'm going to plot that on first. So here we go. I've got a vertical line at x equals 2. That horizontal shift is the only thing that affects the vertical asymptote. That also means that my domain is now from 2 to infinity. My range has not changed, minus infinity to infinity. I don't have a y-intercept because my domain is from 2 to the right. And then in order to find my x-intercept, I'm going to use my equation. I'm going to set x equal to 0 or y equal to 0, and then I'm going to solve for x. So now I'm using my ideas of solving log equations to isolate that x. So I'm going to move the 5 over. I'm going to change to exponential form, which gives me x minus 2. And then I've got x equals 10 to the 5 plus 2. So my x-intercept is 10 to the 5 plus 2, which is a huge number and is 0. So that's way off my chart. So, but now I need to know where my key points are going to go. So I'm going to use blue for my original key points. And I've got 1, 0, and then 10, 1. And so I know that my x value is being affected by my horizontal shift to the right. So my new x value, which I guess I'll do in red, is going to the right too. So my new x value of that key point is going to be 3. My new x value of my 10 point, I'm going to the right by 3. So my new one is going to be, 2. So my new one is going to be at 12. In terms of the y, that is this one right here. So this is my vertical shift down 5. That's going to affect my y's. So I'm going to take my 0 and I'm going down 5. So now I've got minus 5. 1 going down 5 would be at minus 4. So now I can plot those two new points on here at 3 and minus 5. And somewhere over here, 12, 10, 11, 12, and minus 4. And then I'm going to connect those dots to get my log function that kind of looks like that. Let's try, I think there's 2 more examples here. And so here we're going to start off, now we're graphing, we've got a couple more transformations here. We also have a different base of the logarithm. So the first thing to note is that my logarithm is base 4. So the only thing that's going to change is my second key point. So my first key point is 1 and 0, and I'll stick to maybe using blue for that so it matches the other one. So my first key point is 1 and 0. My second key point, instead of being 10 and 1, is now 4 and 1, because this is going to match the base of the logarithm. Okay, so now I'm going to apply my transformation. So the first thing I need to do is figure out what transformations are occurring. So I've got a vertical stretch by 5, and I've got a horizontal shift left by 3. So that means that in my vertical direction, I'm multiplying everything by 5. And in my horizontal direction, I am taking away 3. So let's go to my new key points. So x direction, I'm going left by 3, so that gets me to -2 and 1. And then in my vertical direction, I'm multiplying everything by 5, so I'm still at 0, and then at 5. My asymptote is affected by this horizontal shift, so my new vertical asymptote is at -3. So I'll put that on first, down here with my dotted line, x equals -3. And then I've got my two new key points, -2, 0, and 1, 5. There's been no reflection, so the shape of the logarithm kind of matches the same that I had before. So now I am actually going to have a y-intercept this time, and I'm also going to have an x-intercept. So this time the x-intercept is easy to calculate because it happens to be one of my new key points. To get the y-intercept, I am going to set x equal to 0 in my expression, or in my equation, 0 plus 3, and I'm going to evaluate with my calculator, and I get approximately 3.96 for my y-intercept. My domain is from my asymptote, so from -3 to infinity, and my range is from -infinity to positive infinity. Let's do one more. So this time we've got a horizontal compression, and we actually have a reflection this time, so which is kind of exciting. And then we also have a vertical shift up 4. So let's list those. We've got a horizontal reflection. We've also got a horizontal compression by 1/2. And then we've got a vertical shift up 4. So these first two, these ones are both happening in my x direction. There's been no change to my vertical asymptote, so that one is still there. So I'm going to leave that right at x equals 0. And then my vertical stretch up 4, that affects my y coordinate. So my original points, I noticed that the base of my logarithm is 10. So I've got my key points being 1, 0 and 10, 1. To get to my new points, now I'm going to apply the transformations. So for my x coordinates, I am really dividing by 2, by -2. So my new point is -1/2. And then my new point here is going to be -5. In my y direction, I'm adding 4. So I've gone to 4 and 5, which are my two new points. And then I'm going to plot those on my graph. So I've got -1/2 and 4, and then I've got -5 all the way up to 5. I know that it's been a reflection, so I can see that it goes on the left-hand side of my graph instead of the right, but follows the same general shape. Now filling in my domain, I'm going now from -infinity up to my vertical asymptote. My range has not changed. There's no y-intercept because my asymptote is right there. And in order to find my x-intercept, I'm going to set y equal to 0, and I'm going to solve for x. So I've got -4 equals log -2x. And then I'm going to solve by changing to exponential form, which then means that I get my y-intercept, or my x-intercept, is going to be 10 to the -4 over -2. The last question on here, which I'm actually not sure I can get in my notes, is stating those transformations. So I'll just write it up beside here so I can finish the last question. So we're just describing the transformations of log 2x minus 4. So I notice that this is not factored, which means that I'm going to factor before stating the transformations. This 2 is a horizontal compression by 1/2, just like our last one that we graphed. And this 2 means that there is a horizontal shift right by 2. So when you are noting here, when you are graphing, you're always going to find the key points. Then you're going to use the base graph. So 1 and 0, and then the base and the 1. If you forget, you could always just evaluate for some points, like you're creating a table of values. Then you're going to apply your transformations, state the new vertical asymptote. This is only affected by the horizontal shift. And then you're going to do the general shape. And that is a summary of how to graph log functions.